Hello. So let's go back to what we were doing. So we learned how to add vectors. Subtracting vectors is really the same as adding them. So you just flip the sign and then you just add the vectors as we learned. So you just add vectors by negating it and then adding them up. So let's see what are components of vectors. So what components of vectors are the makeup of the vectors. So the makeup of it in the x direction as well as the y direction. So let's see what we're talking about. So let's say we have the following vector. There is an associated, if that vector is A, there is an associated x direction as well as associated y direction associated with it. So if that's theta, then ax over the magnet by the Pythagorean theorem, and not only by the Pythagorean theorem, like by the Pythagorean theorem, you can evaluate the magnitude of the vector. Just it's ax squared plus ay squared, and that gets you to the magnitude of a. We could also determine it from trigonometric equations. So we know that ax over ay is cosine of theta, and ay, a over the magnitude of a. So how we can write magnitude is that we just draw an a without a sign over it, or we could do it as the absolute value of a. And ay here is also, ay, this is cosine of theta. Ay over the magnitude of a is sine of theta. Yeah, so let's see like the following problem. So we can also determine the makeup of the vectors using, and also the direction as well, by, so if you're given ax and ay, you can get the direction as follows. Tan of theta is ay over ax. All right, so now let's look at finding the components. Okay, so let's see the example 1.6. A, what are the x are the x and y component of vector D. Of vector D in figure 1.19 A. So let me just switch my charger. So going back to draw the vector. So the magnitude, it has the following problem. The magnitude of the vector D is D is 3.00 meters, and the angle it is alpha is 45 degree. What are the x component or the x component and y component of vector E? This is part B. This is part B. The magnitude of vector E is equal to 4.5 meters. So the angle is, we have it as 45, so how it's drawn is like this. So this is vector D, and this is alpha, which is 45 degree, and it's in the negative direction. So you just write dx is, so alpha is equal, dx is d cosine of alpha, so that's 3.00 times cosine of negative 45, which is 2.1 meters, and dy is d sine of alpha, which is 3.00 sine of negative 45. That's negative 2.1 meters. All right, so that is how we resolve those vectors. And let's see what is E here. So I'll leave this problem for you guys to reason through it. If anyone has any question in regards to example 1.6 in the Sears, so the book that I'm following is called University Physics by T. Young and Roger Friedman. All right, and the contributing author is A. Lewis Ford. So I'll keep this video short, and I hope you guys enjoyed this little bit of a problem solving and a little bit about introducing vectors. In the next video, we'll start talking about how to resolve vectors if you have the AY and AX direction, how you can resolve it. And after that, we will be talking about the dot product and unit vectors. So I'll see you guys in the next video, and thank you for watching. Bye now.